So yesterday, good afternoon, all of you. Yesterday we discussed about the polymers, introduction to polymers, how the polymers are classified, how many types of polymerations are there, that we'll discuss. So once again, briefly we'll discuss about the types of polymerization. Types of polymerations are three types. So that are addition polymerization, condensation polymerization, and copolymerization. So in the addition polymerization, exact multiple of original molecule takes place. So that form as a polymer. So in the addition polymerization, double bonds are breakage into single bonds. There is no elimination of any small molecule takes place. So best example for addition polymers: polyethylene, polyvinyl chloride, polyacrylonitrile, and polyvinyl chloride, polystyrene, polypropylene, etc. Now coming to condensation polymerization. Condensation polymerization is the monomers having the simple polar groups, with elimination of small molecule takes place, then form as a polymer. That polymers are called as polymerization is called as condensation polymerization. So in the condensation polymerization, the monomers having the partially positive and negative charges, then that will get the strong covalent bond formation takes place. Then we can't break easily. So like that, polymers are called as condensation polymers. So these example for condensation polymerations are nylon 6,6, nylon 6, bakelite, novolac, and urea formaldehyde, and polyethylene terephthalate, etc. So now coming to next today topic, that is plastics. And one more point is difference between the thermoplastics and difference between the addition polymerization and condensation polymerization. Yesterday we discussed. Now coming to today topic, that is plastics. So what is plastics and thermoplastics and thermosetting plastics? Before we are discussing about the plastics, what is the plastic? What is the important properties of plastics? What are the applications of plastic that we'll discuss now? Now, what is the plastics? Plastics is the material which show the plasticity. Plastic is the material which show the property of plasticity and can be easily molded into any desired shape or desired color, desired dimensions by the application of heat and pressure. That is called as plastic. So plastics means plastic is a material which show the property of plasticity and can be easily molded into desired shape or different dimensions of material by the applications of heat and pressure. So these plastics having the some important properties. That important properties, the properties of plastics are important properties. Any plastic you see, resistance to sunlight, resistance to moisture. Second point is resistance to acid and resistance to alkali, and having the good electrical insulating properties, good electrical insulating properties, good mechanical properties, and having the plastics having the low specific gravity and low thermal and electrical conductivity, low thermal and electrical conductivities. So these all are the important properties of plastics. So plastics having resistance to sunlight, moisture, acid, alkali, and good electrical insulating property and good mechanical properties, and low specific gravity, low thermal and electrical conductivities. So these all are about the properties of plastics. Now, what are the important applications of plastics? So applications about plastics are, so these are plastics are mainly we are used for decorative purpose. So that are mainly, suppose important applications. Suppose for example, first one is the mugs. So these mugs are prepared by polyethylene. So this polyethylene is low density polyethylene. And next one is overhead water tanks. Overhead water tanks. So that also prepared by polyethylene, but these are high density polyethylene. And next one more is pencil box. Pencil box is prepared by polypropylene. These are the polymer compound pencil boxes. And next one, audio cassettes. Audio cassettes that are prepared by polystyrene. Baby feeding water bottles. Baby feeding bottles that are prepared by polycarbonates. Toothbrushes. That are nylons. And cold drinks. Juices, beers, so that are polyethylene terephthalate. And wide necked jars, wide necked jars are also prepared by polyethylene terephthalates, etc. These all are the more importance of plastics. So these all are the applications of plastics. So in that, suppose you see one more so mugs that are prepared by polyethylene. Polyethylene is a low density polyethylene. And overhead water tanks. Overhead water tanks are prepared by polyethylene. That is high density polyethylene. Pencil boxes that are prepared by polypropylene. Audio cassettes are prepared by polystyrene compounds. And baby feeding bottles are prepared by polycarbonates. Toothbrushes, all of them know the toothbrushes. The toothbrushes are made up by nylons. And elastic type garments are there that are also prepared by nylons. And the cold drinks are juices, beers, etc. We have storage now that bottles are prepared by polyethylene terephthalates. Wide necked jars that are prepared by polyethylene terephthalates. And one more is there toilet sheets, colored toilet sheets are prepared by urea formaldehyde, etc. These all are the important applications of plastics. Now, what is plastic? Already we discussed. Plastic means plastic is the material which show the plasticity of, the property of plasticity and can be easily molded and reshaped when we are given the temperature and the application of pressure and temperature. So that is called as plastics. So these all are the applications and properties about the important application properties about the plastics. Once you see, this is the plastic bottles. Just like now, types of plastic products are plastic bags, plastic mugs, plastic coatings, plastic furniture, plastic sheets, plastic fittings, plastic tanks, plastic toys, plastic buckets, and plastic sanitary waste, plastic sanitary, etc. These all are the types of plastic products. Types of plastics are different. Types of plastic products are different. Okay, so these all are by using the plastics like polyethylene, polyvinyl chloride, or styrene, polypropylene, or polycarbonates, or polyethylene terephthalates, nylons. By using these all polymer compounds, we prepare the polymer products. So that is plastic products like bags, coating, plastic coatings, furniture, sheets, fittings, plastic fittings, plastic tanks, plastic toys, plastic mugs, plastic buckets, etc. And plastic sanitary wares and sanitary, etc. are prepared. Once you observe the diagram, that all are the plastic materials, plastic types of plastic products. So once you see, these are the electrical equipments. So these are handles are there. These handles are made, covered with plastics. So that is insulating purpose we are using. Plastic chair, plastic bag, and toys, etc. So plastic, what is plastic? Plastic already discussed. Plastic is a material which show the property of plasticity, and these materials are usually semi-synthetic solids. So in that which one in the plastic, that materials are semi-solid, semi-synthetic solids. Monomers of plastics are either natural or synthetic organic compounds. Plastics. Plastic is a substance that can be easily formed or molded into desired shapes. And plastic can be formed or desired shape by the effect of mechanical force or heat. Now, in the manufacturing of plastic raw material, we are used the coal, petroleum, cellulose, salt, sulfur, limestone, air, water, etc. We are used. In the manufacturing of plastics, to the plastics, we are adding the raw material like petroleum, cellulose stage, or cellulose, salt, sulfur, limestone, etc. we are used. So advantages of plastics over engineering materials. So that is main advantages about plastic material. Low fabrication cost, low thermal and electrical conductivities, high resistance to corrosion and solvents. These are properties. Low fabrication cost, low thermal and electrical conductivities, high resistance to corrosion and solvents. The stress-strain relationship of plastics is similar to that of materials. Plastics reduce the noise, vibration in machines. So plastics, when we are using the plastics, that reduces the noise and vibration in machines. Plastics are bad conductors of heat, are used for making handles, used for hot objectives. Most plastics are inflammable. Plastics are bad conductors of heat, are useful for making handles, used for hot objects. Most plastics are inflammable. Plastics are electrical insulators. Find large scale used in electrical industry. Plastics are resistant to chemicals. Plastics are clear and transparent, so they can give beautiful colors. So these all are the advantages of plastics over the other engineering materials. Low fabrication cost, stress strain relationship plastics. Plastic reduce the noise and vibration. Plastics are bad conductors. Plastics are electrical insulators. And find large scale use in electrical industry. Plastics are resistant to chemicals. Plastics are clear, transparent, so they can be given beautiful colors. So plastics now for decorative purpose also we are using the plastics. Yes. For bottles, once you see the water bottles are available as different colors. Yes, that is transparent, black, blue, yellow, white, etc. colors are available. Okay, all of you, once you read the advantages about the plastics. Naveen,
Sir.
Once you read all advantages of plastics one by one.
Yes, sir. Low fabrication cost, low thermal and electrical conductivities, high resistance to corrosion and solvents. The stress-strain relationship of plastics is similar to that of the metals. Plastics reduce noise and vibration in machines. Plastics are bad conductors of heat and are useful for making handles used for hot objects. Most plastics are inflammable. Plastics are electrical insulators and find large-scale use in the electrical industry. Plastics are resistant to chemicals. Plastics are clear and transparent, so they can be given beautiful colors. Oh. So,
Where are you now?
over, sir.
Over. All of you,
Yeah.
once you read the advantage of plastics, make it fast. Not only Naveen, all of you. Once you read, just a minute. Okay, these all are the advantages of plastics over the engineering materials. So you see, advantage of plastics. Plastics are advantage about the plastics are lightweight and chemically resistant, can easily be shaped and durable, easy to color, thermal insulating properties and electrical insulating properties and energy saving. So advantages or properties are same. That insulating properties and electrical properties, energy savings, and lightweight, chemical resistance, can easy to shaped, durable, easy to color. So you see, these all are the easy color, different types of colors are there or not. So which color you want, that color of a material will prepare. So disadvantages. It is an, so what are the disadvantages about the plastics? Anyone can respond? Anyone? What is the disadvantage of plastic? What is meant by indestructible?
It cannot be decomposed.
Very good, very good, very good. Right, good. Likita, very good. It does not undergo decompose, or that means does not destroy. We can't destroy the material. That like that materials are called as indestructible compounds. So very bad. That means very disadvantage about the plastics are these are we can't be destroyed. We can't be destroyed. So that means indestructible compounds, and when we are melting, when the plastic materials are melting takes place, the fumes are coming to outside, our smell is coming to outside, that is environmental pollution takes place. These all are the disadvantages about the plastics. So plastics is does not plastic is we can't destroy this plastics, and also when melting takes place, when we are burning the plastic material, that fumes are coming to outside, that fumes are environmental pollution takes place. We can't that is not eco-friendly, so bad smell is coming to outside, fumes are coming to outside. So these are the disadvantages about the plastics. Now very important one. So what is the types of plastics? The types of plastics are mainly two types of plastics are there. One is the thermoplastic and thermosetting. Listen carefully, students. So these plastics can be plastics are classified classified two types. One is the thermoplastics and next one is the thermosetting. So what is a thermoplastic? So thermoplastics means when heating soften, cooling harden. Like that materials are called like thermoplastics. Like that plastics are called like thermoplastics. When heating soft, cooling harden. Like this materials are like these plastics are called as thermoplastics. In thermoplastics, it contains a long chain hydrocarbon atom. So that's why in between the carbon to carbon, weak van der Waals forces are present. Weak van der Waals forces are present. Then easily break. So that's why these all polymers are addition polymers. Additional polymers. So best example for thermoplastics are polyethylene, polyvinyl chloride, polystyrene, polyacrylonitrile, PMMA, polymethyl methacrylate, and polypropylene, etc. These all are examples. And these thermoplastics are there. The thermoplastics are easily remolded, easily remolded, and the scrap of materials or scrap of thermoplastics are reused. So these all are the about thermoplastic. Thermoplastics, unheating, soften, cooling, harden. It contains a long chain hydrocarbon atom, so that's the weak van der Waals force are present. The bonds are easily broken. That weaken its property, then easily soften when given the temperature. And these thermoplastics are additional polymers. So that are polyethylene, polyvinyl chloride, polyacryl nitrile, polymethyl methacrylate, polypropylene, etc. So these can be easily remolded, and scrap of materials also we can reuse. And the chemical, we are not storage chemicals in these plastics. Okay, so this is about the thermoplastics. Now coming to thermosetting resins. Under the molding process, become harden. Molding process become hardened. We can't soft. So like that materials are called like thermosetting plastics. So in the thermosetting plastics, the three-dimensional cross-links of structures of polymer compounds or formation takes place. Three-dimensional means like this. In between carbon to carbon, you see. So this is in between the carbon to carbon, strong covalent bond is present. Three-dimensional cross links, and strong covalent bond is present. So that's why when after molding process become hardened, we can't be softened. So these are mainly condensation, undergo condensation polymerization. The example of that one is nylon 6. So thermosetting resins, the plastics are mainly classified into two types: thermoplastics and thermosetting. Thermoplastics that are heat, soften, cooling. Cooling, harden. In between this thermoplastics contain long chain hydrocarbon atoms. Long chain hydrocarbon atoms. So that's why in between the carbon to carbon, weak van der Waals force are present. So that's when easily breaking takes place. That means when we are given the temperature, soften, after cooling, harden. So these thermoplastics undergo addition polymerization. So best example for thermoplastics are polyethylene, polyvinyl chloride, polystyrene, polyacryl nitrile, polypropylene, etc., polymethyl methacrylate, etc. So these thermoplastics are easily remolded, or scrap of metals can be reused. So that is about thermoplastics. Now coming to thermosetting, under molding process that become hardened only. We can't be softened. Why? Because in between the carbon to carbon, three-dimensional crosslinks are present. So strong covalent bond is present that does not undergo any deformation, disintegration, or destroy. It can't be destroyed. So for example for thermoplastic, thermosetting plastics are pressure cooker handles are there, pressure cooker handles and switches that all are prepared by thermosetting plastics only. So that means the bakelite. By using the bakelite, we are prepared the switches. And the best example for this one is nylon 66, bakelite, PET, etc. Well, we can't be remolded. This material, once these materials are broken, or we can't be remolded. So this is about the thermoplastic and thermosetting. Now you can explain what is the difference between the thermoplastic and thermosetting, thermoplastics and thermosetting. Thermoplastics, what are the thermoplastics? Heating, soften, cooling, harden. Thermosetting, molding, after molding, harden, and we can't be softened. Yes? By thermoplastics are prepared by addition polymers. Thermosettings are prepared by condensation polymerization. In the thermoplastics, long chain hydrocarbons are present. In the thermosetting, three-dimensional crosslinks of hydrocarbons are present. So in the thermoplastics, weak van der Waals force are present. In the thermosetting, strong covalent bond is present. So these thermoplastics are remolded. Thermoplastics are remolded. Thermosettings we can't remold it. Scrap of material in thermoplastic, scrap of materials are reused, but in the thermosetting, scrap of materials are not reused. Example for thermoplastics are polyethylene, polyvinyl chloride, polyacryl nitrile, polystyrene, etc. Example for thermosetting resins are plastics, nylon, nylon 66, nylon bakelite, PET, etc. These all are the example for thermosetting and difference between the thermoplastic and thermosetting. Okay, so this is about thermoplastic and thermosetting differences. About this 100% question they will ask in the examination point of view. Difference between thermoplastic and thermosetting, or explain about the types of plastics. So thermoplastics, these plastics can be softened by heating and hardened by cooling. Any number of times without changing the properties of the material. If you are cooling, hardening, cooling, heating, there is no change in the material properties. It is thus possible to shape and reshape these plastics by means of heat and pressure. One important advantage of this variety of plastics is that scrap obtained from old and worn out articles can be effectively used again. The properties of thermoplastics are softens and liquefies on heating and harden and cooling. Retain shape after manufacture. Can be reshaped by heat. It may melt before passing to a gaseous stage. Allow plastic deformation when it is heated. Swell in pressure of certain solvents. That means the thermoplastic swells. Suppose to the thermoplastics we are adding some chemicals that will be swell. Swelling takes place, that is called as vulcanization. Swelling, vulcanization means the rubber is swelling takes place. When to the rubber, to the polymer compound, we are adding the sulfur. The swelling of rubber takes place. So that is called as vulcanization. So these all are the thermoplastics. Once you see the all of you, once you read the thermoplastics, all of you, once the properties, once all of you read the properties of thermoplastics. So these all are the examples for thermoplastics, chairs, tubs, and plumbing items, etc. So water plumbing purpose we are using these all materials. Thermosetting plastics. So thermosetting, these plastics are either originally soft or liquid, or they soften once upon heating, they harden permanently. We can't be softened. So they are available in a variety of beautiful colors. So which one? Thermosetting plastics are available in a variety of beautiful colors, and they are mainly used for engineering applications of plastics. So these are mainly we are using engineering application means, so that are mainly we are using pressure cooker handles, switches, or ball bearings, etc. We are used. Properties of thermosetting plastics: permanently hard on heating above a certain temperature. Undergoes chemical changes during the manufacture. Cannot be melted and reshaped. So which one? These thermosetting plastics, we can't be melted and reshaped. Little potential for recycling. Little somewhat small little potential of recycling takes place. So example and uses: polyester fiberglass systems. Polyester fiberglass systems, sheet molding compounds and bulk molding compounds. We are used polyesters. And polyurethanes, these are insulating foams, matrices, coating adhesives, car parts, print rollers, shoe soles, flooring, synthetic fibers, etc. We are used. Polyurethane polymers are formed by the combining of two to bi or higher functional monomers of oligomers. So bakelite means a phenol formaldehyde, formaldehyde resin used in electrical phenol formal resin is used for electrical insulating and plastic ware. Urea formaldehyde foam used for plywood and particle board and medium density fiber boards. So that are used for urea formaldehyde. Bakelites are mainly used in electrical insulating and plastic ware. Melamine resin used on worktop surfaces. Epoxy resins are used for the fiber reinforced plastics such as glass reinforced plastics and graphite reinforced plastics. So these are about the examples and uses, properties about the thermoplastics and thermosettings. Any doubts, Likita?
No, sir.
What is the difference between thermoplastic and thermosetting?
Well, thermoplastic is something that melts while heating and cooling gets molded. But thermosetting is something that hardens and cannot change its shape
Very
even
good,
after
very
heating.
good, nice, good.
Thermoplastics are something that have weak van der Waals forces, so they break easily, and thermosettings usually have strong covalent bond. Thermoplastics
How we prepare thermoplastics? Addition or condensation?
additional
Very
yes sir,
good,
addition
very good, nice, good.
polymerization, and condensation is thermosetting, sir.
Nida unda? Nida is there? Nida. Kaushik?
Yes, sir.
Nida, what's your roll number? What's the roll number? Kaushik? Kaushik is there or not?
Yes, sir, I'm here.
What's the roll number? So these all are the thermosetting plastics. Examples. So difference between the thermoplastics and thermosetting. So all of you, once you read the difference between the thermoplastic and thermosetting resins. All of you. Rule number 75. Rule number 75.
Sir.
Evaro. 75 evaraya?
Sir, Kalyan.
Kalyan.
Sir.
Who's there? You came?
Sir.
Once you read the difference between the thermoplastic and thermosetting.
Okay, difference between thermoplastic and thermosetting. And thermoplastic resins, these are produced by additional polymerization. Whereas thermosetting resins are produced by condensation polymerization. Thermoplastic resins are made up of long chains attached by weak van der Waals force of attraction. And whereas thermosetting resins have three-dimensional network structure of connected bonds. On heating, these thermoplastic resins are softened and cooling becomes stiff chemical nature, and their chemical nature won't change. And whereas for thermosetting resins, on heating they become stiff and hard, and they won't change on cooling. Chemical nature changes. And thermoplastic resins can be remolded And thermosetting resins cannot be remolded because one set means they are permanently set. Scrap can be used in thermosetting resins, and scrap cannot be used in for thermoplastic resins. Scrap can be used. In thermosetting, scrap cannot be used. The resins are soft, weak, and less brittle. The resins are usually hard, strong, tough, and more brittle in thermosetting resins. These are easily soluble in some organic substances. Example PVC, polyethylene, and for thermosetting resins, they are not soluble in organic solvents. Example nylon, bakelite, and contain long chain polymer with no cross linkage. And thermosetting resins have 3D network structure.
Very good. Right. So, okay, these all are the difference between the thermoplastics and thermosetting resins or thermosetting plastics. Okay, these are the very, very important question for you. Okay, yesterday question and today, any one of the yesterday topic and today topic, any one of the question they'll ask in the examination point of view. Okay. Right. Thank you.
Yes, sir.
Okay. Any doubts?
No, sir.
Okay.